Alright, welcome. So, last thing we did was to add the container config, right? So that now we can tell a container that its max slot size is, for example, 100. And we are using that here, right? When we are trying to get the first free slot in order to add an item, right? And the next things to do now is to implement the stacking. So stacking of an item, a max stack. So far we have not actually created any items per se yet. So this is what we're gonna do now. Let's add a new folder here. And I'm gonna make let's do a U class, can be U object. I'm gonna change it to a U data asset and do IT and call this, let's say, item definition. And I'm gonna put this in a definitions folder. So inventory definitions, inventory data definition. Alright, so inventory data definition, and I'm creating this. Alright, let's do this. So this is going to be our item definition. So what's an item definition? Well, for example, we have a potion, right? So what's a potion? Well, first, the potion has a name, so an item tag, the name potion. It has maybe a rarity, so it can be like a common potion, a rare potion, and a ultimate potion, or whatever it is. It can have, well, it might have like a gameplay effect if you want to actually heal your character. So by what amount does it heal your character? So these are all the information that a potion should have. And we are going to store that in here in the item definition. You might have a weapon, for example, a sword or a staff or something, and they'll probably have something like a attack or magical damage or whatever it is. Well, you can add this here. So let's start. So for now, we're going to keep it simple. So the first thing I want to add is let's change this first. What am I doing? Let's change this to I think it's an engine data asset. I need a data asset. And also I want to include the gameplay tag container. And then I can change this to a U data asset. That's what I want. And make this also blueprint type. Great. Right. So let's make a public section in here and add a U property. It can be edit anywhere, blueprint read write, that's fine. Give it a category of inventory is fine. And F gameplay tag, item tag. So that's the item tag, potion or whatever it is. The U property, I'm gonna give it a bool, be stackable equals true by default, maybe. Yeah. So what is be stackable? Well, is the item stackable? Can we put more in the same slot? If it's not stackable, we should only have one per slot, right? You can't put more on top of it. So, but for potion, I would say that you would want a potion to be stackable, right? So we would set this to true. Yes, it is stackable. We'll add another U property and do int 32 the max stack size. I'm gonna call it max stack size, and yeah, let's set it to 10 for now. Oh, actually no. What am I doing? By default, I'm gonna leave it to 1 because we don't know what this item is yet. So by default, all item will have a max stack size to 1. So we can just edit this in the blueprint. And I'm also going to add something here. I'm gonna add a meta equals. I'm going to clamp minimum equals 1. Okay, what does that do? Well, it's clamping the value of max stack size to 1. So in the UI there, in the blueprint, you won't be able to set this to 0, for example, because it doesn't make sense to have something stacked at 0, have a stack of 0. If you have a stack of 0, then you don't have any stack, right? So you should at least have a minimum of 1 item. You can't have 0 negative 1 of an item. So a stack should at least have 1 item. So a max stack size should have a minimum of 1 in it. So that's why I'm enforcing this here. And I'm going to add an edit condition. Be stackable indeed. And do edit condition height. What that do? Well, it's just checking the value of bstackable. If bstackable is true, then make this visible. If bstackable is not true, then hide this. So we'll only see this if we set bstackable to true. That's all that this is doing. And now we have an item, and also this, well, we can leave that empty for now. We don't need anything now. So now we have an item definition. I'm going to need a item database. So we are going to put this item definition inside of a database, and then we'll give the database to our inventory, so that when we have an item to add or something, we can just look up inside of the database, say, oh, we are trying to add a potion. Well, we need to know what's a potion. So we go and look inside the database, find the definition for the potion, and then we'll have all this information. So is the potion stackable? What's the max stack of a potion? What amount does it heal for? And all of that stuff. So let's make a database. So in my data folder, actually here, let's make a new folder. And I'm gonna call this one databases. Yeah, that's fine. Same thing here. IT. I'm gonna call this item database. Yeah, that's fine. Yeah, item database. Inside of databases. Yeah. Let's clean this up. Good. And change this again. This should be a engine/data set, and also we will need the gameplay tag container, and change this to a data set. Great. Oh, and don't forget to make this blueprint type, so that we can create one of them in the blueprint. And now we can actually we need to include the data definition, inventory first, then data, then definitions, and the item definition. Actually, the item definition.h already contains this container tag thingy. Yep. So if I'm including it here, then I don't need to include this, because it's getting included from that file. So no need for that. All right. Let's add a public. And let's make a uProperty. uProperty. We can do blueprint. We can do edit anywhere. Blueprint read write. Blueprint read write is fine, and a category of let's say database. Okay. Now let's make an array of. I'm gonna use the object pointers of u it item of definition. I'm gonna call it actually item definitions. Alright. So now I have an array of item definitions. So I can have multiple of these inside the array. Okay. You have an array of them. Now I need a function to retrieve a definition from the array. So we have the array. Now to simplify our lives, we can just have a function that we give it a item tag, and then it's going to go inside of the array here and find the definition that corresponds to that tag and give it back to us. So let's make a U function. Nope. Blueprint callable is fine. Database is fine. And let's do a const UIT item definition, get item definition. I'm gonna call this get item definition by tag. Alright, and let's implement this. Okay, so let's implement the item definition. So the first thing I want to do is to make sure that the item tag is valid indeed. Return null pointer if it's not. Alright, now we can loop over. So I'm gonna do const item definitions. Item definition, loop over all the definitions, and then do if is valid item definition. If we have a valid item definition and that valid item definition has an item tag that is the same as the one we are looking for, then we have a match. We can return it. Great. Otherwise we just return null pointer because we didn't find anything. Great. So that's done. Let's close that. Don't need that anymore. Don't need that, and I don't need that. Now I'm gonna go to my item component, and right here add the edu property, right, and add a t object pointer u item item database, and don't forget the include. So now my inventory component has a database that we can use to look up information about the item that we are trying to add to the inventory. So I'm gonna set this to null pointer by default also. Great. Now let's use this item database actually. So I'm gonna go to my inventory component here, and right here, right after I'm checking for the container max slot, I'm gonna add a new int 32. I'm gonna do item max stack size, and we should have a function also that will take an item and go inside the database and see what its max stack size is. So let's do that just like we did for this one. So I'm gonna come here and do an int 32 get item max stack size. It's going to take in a const, a tag, but a tag for item tag. There we go. Now let's implement this. Okay, now when we are inside, we just make sure that the item database is valid. Otherwise, we return 0. And now we can do a const UIT item definition. That's what we are trying to get, an item definition. I'm gonna call it def. We can use the item database and use the function that we made inside of it, passing in the item to get the definition. If the definition is not valid, we can return definition. Make sure the item is, let's check if the item is stackable first. question mark. So if it's true, if the item is indeed stackable, I'm going to do an fmap and do a max 1 def max stack size. So what this is just a protection. You can't have an item that has a stack of 0. That doesn't make any sense. An item should have a minimum of 1, right? Because you can't have 0 of any item. So what this is doing is just checking which is the biggest number between max stack size and 1. So if, for example, max stack size is 0, then it's going to return 1. Otherwise, if max stack size is bigger, let's say 10 or something, then it's going to return the 10. So this is just the security so that we don't return 0 as the item max stack size. That's all this is doing. And otherwise, so if this is false and the item is not stackable, shut up window. If the item is not stackable, then we just return 1, because an item that is not stackable should have a stack of 1. It can have a stack of 0 or more than 1. So it's not stackable, you can put more on top of it, it should return 1. Great, and now we can use this here. So get item max stack size, passing in the item tag. And now we should pass that in the function here also. So let's open the I'm gonna open this, and item max stack size, and also here const int 32 item max stack size. Great. And now from here we can now pass that in item max stack size. Fantastic. All right. Let's use that information now. So where I'm gonna use this is first actually here in where I'm doing all my checks. Let's first here where I'm doing all the checks. Let's check if the container max stack size is 0 or less. Then we return, and same thing for the item. So that's that. Next is in here where I'm trying to add an item to an existing stack. So if we found we are trying to add a potion and we found in the inventory that we already have one, then here we are trying to add to that stack. So this is where I'm gonna use this stack implementation. So let's do if the entry.quantity is greater or equal to item max stack size continue. So what we are checking here is, well, let's say the potion can stack up to 10. We've set a limit of 10 per stack. If the quantity here is 10, so we already have 10 in the inventory, and we know the max stack size is also 10, well, there's no point in trying to add anything to that or existing stack because it's already at its full capacity. So that's what this is doing. Just checking, is the entry that we found, is the potion already at full capacity? Is it already at its max stack? If it is, no point in trying to add anything to it, we just continue. Cool. So that's that. And what else do we want to do? I'm actually going to get rid of this. Don't think we need this here. We're gonna do this in a different way. Alright. So let's do a const int 32 space left equals, let's do item max stack size minus entry.quantity. Alright. So what I'm trying to find out here is, well, we found an entry in the inventory, a potion, right? And let's say there's 2 potions in that stack already. And we know that we can stack up to 10. So I want to know what what's the space left? How much more potion can I stack in there? Well, I'm just taking the max stack size, which is, for example, 10, and subtracting the existing quantity already. So if the existing quantity is 2, then we know that space left is 8. So we have 8 more space in there to stack the potion. Great. Let's do a const int 32 to add, and an fmath mean space left and remaining. Okay, so what this is doing, so what is the quantity to be added? How are we gonna find out how much we should add in this slot right here? We check of these two, which is the smallest value, so space left or remaining. Why? Because let's say space left is 8, like I was saying before, and remaining item to add to the inventory is 10, right? Well, we only have 8 slots and we're trying to add 10, so space left is the smallest number here, so the quantity to add will be 8, and then after that we can just take whatever we've added, which is 8, and then remove that from the remaining, which was 10 at the beginning. So now we know that remaining is now 2, so we've added 8 items and we have 2 remaining. So here we are only, so the only thing what we are doing, just comparing the two, just checking if space left is the smallest number, we set to add to that value. If remaining is the smallest number, so for example if we have 8 space left and we are trying to add 6 potion in there, well 6, so remaining will be the smallest value, so 6, so to add will be 6. Simple, hopefully. So let's just add a check here, so to add a and continue. Let's just make sure that we do in fact have something to add. Great. Now let's do, I'm gonna put a comment here, increase the stack. So we know what amount we can add to it, so I'm just gonna take the entry, take the quantity and do a plus equal to add. So we take the entry and we add this to it. So for example here we had a stack of already 2 existing, and then let's say we are trying to add 6 to it. Well, we take our 2 and we add the 6, so now we have a stack of 8. Fantastic. And let's do a reduce what is still left to place remaining minus equal to add. Oops. All right. In this case 6 was the amount that we tried to add, and we did in fact add 6, so this will be equal to 0, right? So 6 minus 6 is 0, so we don't have anything remaining. Now if we were trying to add 10 items, for example, and we only had 8 slots left, then we added 8 items, so that's correct, and then we would take the 8 items that we added minus the remaining 10, which would give us 2, so now we have remaining is equal to 2, and we've added 8 items. Fantastic. Next, let's do record how much the operation successfully added. Okay, response, indeed, that is what I need. So remember, we have this response that we need to return later after all of this is done, so let's update that. So let's update the added quantity. Well, this is what we've added so far, and then we mark the item dirty so it can replicate after we've done the addition, and that's pretty much it. And that's just our comment for not comment, that's the log. We'll keep it for now. Yep, let's go to this part now. So this is where we were trying to, where we actually had an item and we were adding to that stack already. Now here is where we did not find any item, or maybe we did find an item but it was already full, so we could not put more inside of it. So now we go to here where we need to find a empty slot to put whatever we have left inside. Actually, let's put it checked here. I didn't do that earlier, so let's do a free break. Okay, so if the index that was returned is index none, we just break out of the loop. Just a security measure. Okay, and let's do a const int 32 new quantity. I'm gonna do an f math minimum remaining and item max stack size. Alright, and let's put a comment to explain this. If actually, let's do this. If remaining is smaller than max stack, use all of it. Otherwise, create a full stack and keep looping for the rest. There we go. So new quantity is what, so we check what's the smallest number between whatever is remaining and the max item stack size. So now that we have new quantity, I'm going to set this here to new quantity. Okay, new entry, we are creating a new entry, we set its value to a new quantity. And remaining, again, now we can do new quantity. Okay, so again, if we were trying to add 12 items, let's say, and we can only stack up to 10, well, we check, we just take our remaining, which is 12 for now. We've added 10 items, so remaining is now 2. Same thing here. So added quantity is new quantity. That's what we've added. And the rest can be the same, because after that we're just logging what happened, and then we are telling the array and the item to replicate. Perfect. Yeah, I think that's it. We can just test this out now. So let's compile. Okay, back in the engine, let's go back to the player controller, and so we have a container. We have a player inventory. It has a max slot of 100, and here is where we can add our item database. So we need to create that. I'm gonna go to content here, make a new folder, call it data. Inside of data, I can make a, where is it, miscellaneous, and find this one, item database, the one with the Pac-Man icon. And then we can create, I'm gonna make an item definition first. I'm gonna call this DA because the data asset, so that's the prefix, and I'm gonna call it potion. Okay, we need a tag. So what this is a potion item. It's stackable, so as you can see, we did this. So if I put stackable to false, it disappears, and if I click it again, then we can see the max stack size. So I'm gonna do 10, so it can stack up to 10. Oops, here, and now I'm going to create a data asset again, same thing. This time I'm gonna make a database, so DA item database. We could also, for the sake of like organizing this a bit more, we could make multiple databases, like a consumable database, a weapon database, and all that. But I don't want to complicate this too much, so I'm just going to keep it simple and just make one database and just put everything in there. So we can add a new entry and add our potion to it. So later we can add a weapon or whatever it is that we create later and put all that in here. So item database right now contains only our potion. Great, so now we have a potion and an item database that contains this potion. Awesome. So now we can set the item database here so that when we try to add something, it can go and look up the definition for the item inside of this database. Fantastic. And I think we can just test it now. Yeah. So I'm gonna press play, just clear this log, and I'm gonna press 1. Actually, you know what? Before I do this, let me change the amount that we are adding. I'm gonna add 5 items instead. So let's add 5 potions instead of just 1 at a time. Alright. So if I press 1, I see create new entry in slot 0, which is correct. It's the first time we are adding anything, so slot 0 is the free slot that we can find. We are adding 5, which is correct. So the result of all of that is we added 5 with 0 item remaining to be added, and it was a full success. So great. If I press this again, boom, we see we stacked now. It did not create. The first time it created a new one. Now we stacked into slot 0. Current quantity is 10, so we successfully stacked into it. And the result of all this is we added 5 items, 0 remaining, full success. So great. Now, if I press this again, what I expect to see is it to create a new entry, because now this is full, right? So our slot 0 is full. It has 10 potions inside of it. We can't add more into it. So we should make a new entry in slot 1 and add the 5 inside of that. So let's press 1. And indeed, that's what we see. So create new item. So we've successfully added the ability to add an item to our inventory. Now we don't have any visuals yet, but before we add the visuals, I would like to also first add the ability to remove an item from the inventory and maybe swap an item also. We'll see. But definitely we'll have to, I want to do the remove because that's very easy to do. It's much easier than actually adding an item. So we'll do that next, and then maybe we'll work on the UI. Yeah. Alright, anyway, subscribe, leave a like, comment if you have questions. There's a Discord you can join if you have more questions. You can if you want more clarity over something, you can ask me there. I do have a Patreon also if you want to support me. It has the project file and the next tutorial already uploaded there. And yeah, hope you've enjoyed. See you in the next one. Bye bye.